What's up, everybody? These are the 20 hardest advanced math questions on the SAT, in my opinion, and they're not trick questions. These are the types that show up on most tests most of the time. There's some custom regression stuff in here and other Desmos tricks that make your life a lot easier if you know them and really difficult if you don't. I tutored this test. I scored a perfect 800 on it. You can watch me do that in the speedrun videos on this channel where I rip through every blue book test that exists. And these are 20 questions that my students frequently struggle with, and they're not really obvious if you haven't seen them before. Now, here's how to use this video. When a question comes up, pause it before I break it down and try it yourself. You can find the timestamps in the description. Then watch how I solve it and check if you did it the same way. Because on this test, the method is the difference between 40 seconds and 4 minutes on some of the problems. Let's go. The function p is defined by p of x equals a square root x plus b, where a and b are constants. In the xy plane, the graph of p of x passes through negative 36, 0, and p of 36 is less than 0, which of the following must be true. This is a regression problem, right? It's kind of a harder one because, you can't, they don't have a square root function, right? So you add a table and you put in your 2 points. But before that, how do I know it's a regression? Well, basically, anytime they give you an equation and it has like coefficients in there that you don't know, and the question's what are those coefficients or whatever, yeah, that's a regression function, right? You need 2 points, right? Here's 1 point very clear. This other point's in function notation. It just means when x is 36, you see p of x, p of 36. When x is 36, the result is less than 0. Doesn't matter what you use for y, just make it negative, right? There it is. I'm going to use -4, right? And then I'm just going to write my regression, right? It's really simple. Instead of y, this is your y. Instead of y, you write y1. Instead of equals, we write a tilde, right? That tells Desmos to do a regression. And then we write a square root. Instead of x, you write x1 plus b, right? And you see it tells me my a and b. So again, to recap that, just 2 changes you make. Your variables, you got to use x1, y1. Because that's, you see, that comes from the table. That's telling Desmos, hey, look at my table, right? And then instead of an equals, you write a tilde, right? That's the key next to your exclamation mark or one key on, your keyboard, right? You press shift and the one to the left of it, that's your tilde. And that's it, right? And you see, I get my a and b, right? And so what do I know? Well, you see, I know a is negative, so it's not a is greater than 0. And then I know b is 36, so yeah, it's d, right? So pretty simple if you understand this is a regression situation and you feel comfortable taking any equation they give you and translating it into a regression, right? That's it. All right, next one. The given equation relates to variables n, t, w, where n is greater than 0, t is greater than 0, and w is greater than t, which expression is equivalent to n. So basically, they want you to solve for n, right? That's the idea here, right? We got to get, all of these are basically saying n equals, right? So algebraically, you'd have to manipulate this to get n by itself. That's going to be a little tricky, right? Here's how you can do it in Desmos instead, right? So if you type this in, Desmos won't graph anything because Desmos doesn't like that you aren't using x, y, and numbers, right? So that's all we do. We change it, right? I'm going to change n to be y. I'm going to change t to be x, right? And I'm just going to put a number for w, right? So we'll go with 4, right? So now I have a graph. And now one of these has to be the same exact graph. That's what equivalent means, right? They have to be identical. So again, here though, you have to write again, n equals, right? So these are all like this one's n equals 15 TW, right? But we got to replace, n was y, t was x, right? So times x, and then w is 4, so times 4, right? Is that the same thing? No, that's not the same graph, so that's not the right one. So next one, it's going to be n equals, so y equals 5, and then it's x minus 4. That's not it either, right? So then maybe c. C would be w, which is 4, minus the t, which is x, over 5 times t, which is x times 4. Is that the same? No. So that's not it. Maybe the next one. You see the next one is basically the same one, but flipped over. So I just got to put 4 minus x on the bottom. And on the top, we're going to write 5 times x times 4, right? And you can see those are exactly the same, right? So if you know this hack, saves you the algebra. You don't have to solve that, but you can solve that algebraically as well. Just it would be a little bit annoying to do, but you could do it if you prefer. But this is the Desmos way. So D, let's see. Yep. All right. Okay, next one. In the given equation, k is a constant, the equation has exactly one real solution. What is a minimum possible value for k? Okay, this is a tougher one, but it's still a discriminant problem, right? So this one's tricky though to know this is a discriminant, right? Because for a discriminant, you gotta have a quadratic. This doesn't look like a quadratic, right? But the thing is, if you were gonna solve this for x, what would you do, right? Like if I have this, let me write it in. If I have this, what am I going to do? I'm going to square both sides, right? That's how you would start this problem, right? And that's where the quadratic comes about. So this will be k minus x. On this side, I'll just write 42 squared. The middle term is 42 times negative x times 2, so it's negative 84x plus x squared, right? Now for the discriminant, you need a quadratic. We have it now. You got to set it equal to 0 so you can get your a, b, c. And then, you got to know what case to use. And so it was this one, this middle one, because it does say the equation has exactly one real solution here. They almost always tell you that, and it's almost always the second sentence. That's how you can kind of like be like, maybe this discriminant, even if it doesn't look like it right away, right? Most of the time, they're a lot more obvious. You can just see it's a quadratic, right? That's what makes this one tough. What do? We got to set this equal to 0 so we can identify a, b, c, right? So I'm just going to write x squared, and then you see you would add x to the other side. So it's going to be minus 83x, and then it's plus the 42 squared. We can leave that way. You don't have to worry about that. Minus k to set that equal to 0, right? So a, what is a? A is 1, b is negative 83, and c is this. Again, you could just leave it like this, 42 squared minus k, right? So now we got our A, B, C. Again, you got to fill this into Desmos then, right? Plug in your B, A, and C, right? Put them in parentheses, especially this one. You see, if you don't put in parentheses and you square it, it won't square the negative. So negative 83 squared minus 4 times A, which is 1, times C, which is 42 squared minus K, equals 0 for one solution. Last step, right? Your unknown is always going to be some other letter. You got to change it to x, so Desmos will show you the solution. There it is. 41.75 is what k is, right? Now, the last tricky thing in this problem is they didn't want k, right? What did they say? What's a minimum possible value for 4k, right? So I'm going to take this and multiply by 4. That's my answer, 6,167, right? That's a hard one, probably as bad as they'll get for like those discriminant ones, right? But if you understand that, it shouldn't be honestly worse than that. All right, next one. The function p models the population in thousands of a certain city t years after 2010. According to the model, the population is predicted to increase 3% every n months. What is the value of n? Okay, so this is your exponential equation, right? Two parts to it. You have the number in front, that's the initial value, and you have this number inside, which represents the increase or decrease, right? If you see 1.03, right, that's telling us it's a 3% increase. That's what they're kind of telling us here. But they're telling us it's going to happen every some amount of months. They say n months, and they want to know what that is, right? What that has to do is with your exponent, right? This question's about the exponent. So 180 is the initial. We know this would increase it by 3%, right? So you see, if you want to increase something by like any increase or decrease, you want the exponent to be 1, right? That's the whole trick to this problem. That's how you solve this, right? Because if you had like a 2 here, it would do a 3% increase twice, right? So to increase it by 3%, it would just be this calculation. So what does that mean? It means you want to make this exponent equal to 1. You want to figure out like what would make this equal to 1. So you solve this, just multiply by the reciprocal. It's going to be t is 2/3, right? But what was t? T was years, right? They don't even have that as an option, so don't worry about that. But it's 2/3 years. So then you finally have to change years to months, right? So I'll just multiply by 12, and I know 2/3 years is 8 months. And that's the final bit of this question, right? But you'll definitely see that again about understanding like the exponent has to be 1 for that increase or decrease to be applied, right? Okay, next one. The table shows the 3 values of x and their corresponding values of h of x, where h of x equals px over x plus 5, and p is a linear function. What is the y-intercept of the graph of y equals p of x? Okay, wow. This is a tough one, right? This is definitely kind of a tough one. So h of x, right? They tell you is p of x over x plus 5, right? This is going to be a custom regression problem, right? So one thing that makes this tricky is they didn't even write the full equation for you here. They just tell you p is linear. So you want to know, you should replace that with our linear equation mx plus b, right? Now, Desmos can tell you what m and b are going to be if you give it a few points and you write a regression statement, right? So this is what we're going to do. We're going to add a table. We're going to put in our points here, right? And then below that, I'm going to just tell Desmos what equation I want, because this equation isn't in the Desmos, right? Like normally you could do regression and you see they got some of them. Linear we use a lot, quadratic sometimes, even exponential sometimes. That's really it, right? So if you want anything else, right, like this one, you got to know how to write it yourself, right? So here's how that's going to work. H of x is really like y. So there's just two things you change. Instead of writing y, you write y1. And instead of writing x, we write x1, right? So it's going to be mx1 plus b and then x1 plus 5. And nothing crazy about that, right? It's just going to be literally like, you write y and then the one key afterwards, right? There's one final thing, and that's why we got an error here. You see, you want to change your equal sign, you got to use a tilde, right? So that's going to be the key that's next to like the one key to the left of it, right? Typically you press shift and that, and there you go. And now you see, I told it what regression I want, and then it's just going to give me my m and my b. And the b is the answer because they said they want to know what's the y-intercept of p of x. So it's like the y-intercept of the linear function. That's what b is, right? So our answer here is just -15. This is a tough one, right? You got to kind of understand this custom regression idea to like master this kind of problem. The good news is these are not very common, right? But the bad news is if it is on the test and you don't know how to do it, then probably not going to get it right. You could do this algebraically. It's just not like a great time. Algebraically, I won't show it to you just because it's a pain, but you just would make a system. You plug in like for this for x, this for y. That's one equation. This for x, this for y. Then you have a system. And you can actually, it's not too much of a pain because then you could have Desmos solve it, right? But yeah, that would be it. Actually, let me show you that. Why not, right? So -20, like if I plug this in for x and y, it would be 5 equals m times 20 plus b, and down here 20 plus 5. That's one equation. The other equation, let me plug this in. Maybe this actually isn't honestly that terrible. If I plug in y for 0, 0 equals m times 5 and then plus b, and then on the bottom 5 plus 5. We got our two equations, right? So now if you want Desmos to solve this system, the only thing is you have to change your m and b to x and y. So I'll change m to x and I'll change b to y. And now we should see equations pop up and we can click where they intersect. The reason it's not the same answer is I put in 20, but these were -20s. Let's change that. And there it is. Now we get the same. You see m is 3, b is -15 that we had over there. So honestly, that's actually not too bad. So if you prefer to do it that way instead of like trying to learn how to write this regression, that's not too bad because that's basically what Desmos is doing when it does the regression, right? It's just making a system, because you need a system if you have two unknowns, right? So making a system and solving it for you, right? Whatever you prefer, right? But that's more of an advanced thing here, right? So hopefully one of those two methods makes sense to you. All right, next one. The functions p and q are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines? All right, this question is actually a lot simpler than it seems, but anytime I have a student, I'm working with a student, they read this for the first time, they have no clue what it's saying, but it's actually pretty simple. So let's talk about it, right? What's the constant or coefficient, right? So this number here, for instance, 24, we call that the leading coefficient. 1.3 is your base coefficient, and 17 in this example would be a constant, right? So this question just wants us to look at the equation and figure out which of these equations, if either of them, show the maximum value, right, for x greater than or equal to 0. So to know if they're showing it or not, we first have to know what the maximum values are, right? So, you type these in and here it is, right? So for this one, if you type this one in, and you look from like x greater than or equal to 0, you see that's kind of like looking from like the y-axis onwards. There is no maximum value. This thing just keeps going up for x greater than or equal to 0, right? So 1, there's just no maximum value for this, right? So it can't be 1, okay? Then we go to q of x, right? Q of x equals 14, and it's 0.85 to the x, right? This one, you see, we're looking again from like the y-axis onwards. That's x greater than or equal to 0. That would be the maximum value, right? Because that's the highest point, right? And so our maximum value is 14. And the question is basically, again, just saying, does this equation show 14 as a constant or coefficient? Yeah, it's the leading coefficient here, right? So we want 2 only, right? You'll see other versions of this that ask you to find other things, right? Like I've seen another one ask you to find the y-intercept, and then is the y-intercept one of the constants or coefficients? So another one just asks you to do like f of 1, is f of 1 a constant or coefficient? So yeah, it's not actually too bad if you've kind of seen it before and you understand that it's just asking you to find something and see if that number you find is one of the numbers of the equation, right? Okay, next one. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object is launched off an elevated surface. The model indicates the object has an initial height of 6 feet above the ground and reaches the maximum height 518 feet 8 seconds after being launched. Based on the model, what is the height of the object above the ground 12 seconds after being launched, right? Wow, a lot of information there. What did they tell us? They told us the initial and they told us the max, right? So what you kind of want to know with this is, you know, because it's a quadratic, they tell you at the top, right? It's going to have this shape because it reaches a maximum, right? What's important when you have a maximum, you know the vertex, right? And the vertex is important because the vertex is a point of symmetry, right? And so you see, if you have one point on one side of the vertex, you automatically know another point on the other side of the vertex, right? That's the symmetry part, right? Why is that important here? Well, you can get Desmos to give you this quadratic function, right? You just need to do a regression, right? So our first point is they said the initial height, right? The initial height, you got to know your interpretations as well, right? That would be helpful. Initial height, that's your y-intercept. That's another way of saying that, right? So 0, 6. And then my vertex is 8, 518, right? But you see, now I'm going to use my symmetry, right? If I know that, you know, let me zoom out here. Can I show them both? Yeah, I can show them both. If I know it took 8 seconds to get from 6 to 518, it's going to take another 8 seconds to go back down to 6. So my third point is this, right? Why do you need a third point? Well, I'll show you in a second, right? Quadratics need 3 points. You see, if I don't, this is my equation, right? But you see, if I get rid of this point, it's not the same equation anymore, right? It assumes the third point is something else. I don't know what it'll assume it to be, right? I think normally 0, 0, but I don't know if that's the case here because we already have 0, 6. Anyways, you need 3 points, and the symmetry is how you get your third point, right? Now I got my function, you see. Now I can just change this to f of x, and then I can just plug in 12 for x the seconds, right? And I just get my answer 390, right? That's how you can do that with Desmos, but for quadratic regressions, you need to remember you need 3 points. All right, next one. The area of a rectangular poster is 3,480 square inches. The poster's length is x in inches, is 18 inches longer than its width in inches. Which equation represents the situation? So they basically, you'll see this question more in geometry, right? But they basically want us to fill in an area equation for a rectangle, which is just length times width, right? Area, they tell us, 3,480. Okay, now we got to fill in length and width, right? This is where people are going to mess it up, right? They're gonna think this is x and then x plus 18, right? That's the mistake people are going to make because they read 18 inches longer, right? But here's why that's not going to be it, right? And why you got to just read carefully. They told you in this case, right? They told you that length is x, right? It says the length x, so we'll put that in there. And they continue describing length. The length is 18 more than the width, right? But you see, I already made length x because that's what they told me it is, right? You got to think about width the other way around, right? So if length is 18 more than the width, that means the width is 18 less than the length, right? So you really want to express the width part as x minus 18, right? Make sure that makes sense because you will see this. If you do geometry problems, they love this in geometry. It's here in nonlinear functions because technically this is quadratic, right? But it's more of a geometry concept and wording basically, right? Anyways, then what do? You distribute your x, it's x squared minus 18x, and then they want you to set it equal to 0. But that's why we want x squared minus 18x, not plus 18x, right? So yeah, a lot of people are going to pick this one. That's the wrong one. That's the trap. You want this one, right? And that is it. Okay, next one. The rational function p is defined by an equation in the form p of x equals a over x plus b, where a and b are constants. The graph y equals p of x is shown. If q of x equals p of x plus 5, which equation could define q? Ooh. All right, there's a little bit going on here, right? First, we need to know this equation for p of x, right? If you have an equation and it has like unknowns, like these coefficients are unknown, right? You need to do a regression, to figure that out, right? So we're going to add a table, right? And we're going to take 2 points from this graph. Here's some nice points. -7, -2 is a nice point. And then we got over here, -6, -3. That's another nice point. You can even have a third point. You should be good with 2 points, but, you can put in a third point. And then I got to enter this as a regression. You got to know how to do that, right? Because if you go to just click regression, it obviously just doesn't have this function, right? This is a rational function, but they don't even have a rational function here, right? Doesn't matter. You can enter any regression yourself if you know how. Here's how. You replace p of x with, it's really y, so you write y1. It's literally press y and 1 right after it. And then for an equal sign in a regression, you got to replace that with a tilde, right? So the tilde is the key. It's next to your exclamation key, next to the 1 key, right? That's your tilde key. And then you just type in the rest of it. A is A. You replace x with x1 and then plus b, right? The reason we're replacing x and y with x1 and y1, it's this table up here. You see the table, when you add a table, it's going to say x1, y1. Sometimes if people have 2 tables, it messes them up because the other table is going to say x2, y2. Just be careful, right? That's why I delete the table. Just make sure you have 1 table. You don't have to worry about it. But now you see, I know, my a and b, so I can say this, p of x equals 6 over x plus 4, right? And then we can see that, yeah, this is basically that same graph that we see over here, right? Why did I want to do that? Well, now you see, I can tell it q of x is p of x plus 5 because Desmos knows what that is. And yeah, this makes sense, right? It moved left because when you write this, right, from your transformations, that's a shift left, right? And it's left 5 because x plus 5 in here, right? Cool. How does this help us now, right? Well, we know what q of x is, right? One of these is q of x, right? So, you could just go ahead and enter these in for q of x, right? Like 6 over x plus 9. Is that the same thing? Yeah, it's the same thing. You see, if I turn it off, they're exactly the same. How could I have done that as well, right? Well, look what this is telling you, really, right? It's telling you plug in x plus 5 into p of x. So you see, if I take, my p of x and I replace this with x plus 5, it would be x plus 5 plus 4. That becomes what? X plus 9 on the bottom, right? So you could solve it that way as well. This is a pretty tough problem. If you could do this and you have no issues, you know your stuff, right? Not going to really get any worse than that. All right, next one. Which expression is equivalent to all of this? Oh, wow. So this looks not fun, right? Like if you had to do this with algebra, this would be, kind of annoying, right? But luckily, you don't have to do it with algebra if you know how to do it with Desmos, right? So with Desmos, what's going to happen, right? You see, if I type this in, nothing happens, right? And we got to understand why. Well, when you mix x and y like this, you need it to be an equation. So it needs to equal something, right? So just make it equal to 5, you see, and here's my graph now. Now, equivalent means, again, one of these answer choices have to be the same. So I can go ahead and put these answer choices into Desmos, right? And also equal them to 5 and see like what matches, right? So it's not fun, but it definitely beats, the alternative, right? So, which is doing the algebra. So here, I'm putting in a here, x cubed, y minus 12x squared, y plus 36xy equals 5. Do those match? No. Okay, so let me not delete everything because you see here, A and B have the same denominator, right? Just make sure. So you see, I just got to change the numerator. That helps if you don't have to rewrite everything all the time. And that's this one. So do those match? And yeah, the answer is no. That doesn't match at all, right? So it's not A or B, right? So it's got to be C or D, right? So, let's go with C next. XY plus 9y plus 10. And on the bottom, it's going to be, let's see, x squared y minus 6xy plus x minus 6. Okay, that's not it. So it's got to be D unless I just read one of these wrong, but let's try it out. Sometimes that's it. You just got to suffer and go through all of them, and it's the last one. X squared y minus 6xy. There it is. They match, right? So we didn't enter anything in wrong. See, I turned off the red color. There's a black one underneath it. These are the same, right? So again, in my opinion, that beats doing the algebra. It's up to you what you decide. But yeah, you can easily lose like 5 minutes doing that with algebra. But if you can just type it in like this and look for a match. Probably much, much better, right? That's it. But that's a tough one. Okay, next one. In the given system of equations, A is a constant. The graph of the equation in the given system intersect at exactly one point. What is the value of x? So this isn't that simple, even though it's a system, right? You got to first figure out, right, where will they, like for what value of A will they intersect at one point? And then once we know that, we can actually plug it in and then see the intersection and answer with x, right? So sometimes people do this one correct or halfway correct. They get the A and they think that's it, but it's not, right? So what should we do for this one? Well, they tell you that they intersect at one point. You have a quadratic. Hopefully to you kind of know that you should use the discriminant here. It's a very common problem. The SAT loves this problem, right? And the discriminant, you need a quadratic, and we have it here, right? 3x squared. The first equations are quadratic. And you need a quadratic that's set equal to 0 so you can identify your A, B, C. And then you got to remember these three cases to know like what to type into Desmos, and that's basically it, right? So let's go ahead and do that. So because it's a system, you'd first have to set them equal to each other and then set it equal to 0. So it looks something like this. And then we set it equal to 0, 3x squared minus 24x if I subtract 6x, and then plus 44 minus a equals 0. So a is 3, b is negative 24, c is 45 minus a, right? So that's my ABC. So what do? Then I just type in my discriminant, b squared, so negative 24 squared, minus 4 times a times c, and we're going to equal that to 0, right? And the reason we're not seeing an answer yet is your unknown in the discriminant. You always got to make it x. So there we make it x, and here's my solution. That's what a is, right? I just changed it to x so we can see it, but a is negative 3, right? So now we know a is negative 3, right? So I can get rid of all of this, or I'll just hide it for now, right? We got that. So now I can put in my two equations, right? And the other one, 6x plus a, it knows what a is. You can see they intersect one point. I can click on it, and then I can see my x and y. Now I can finally answer the question, what is x? X is positive 4, right? So basically a discriminant problem, and at the end you just put in the equation and, see what x is, right? So hope that makes sense. That's a tough problem, but a really common thing you can see. All right, next one. In the given equation, c is a positive constant. Which of the following is a solution to the given equation? So there's an interesting problem, right? Solution, right? We like solution. Solution means we could just type it into Desmos and get a solution, right? Not quite here. Yes, but no, right? So if I type this into Desmos here, you see c squared over square root x squared minus c squared plus 47. If I type this into Desmos, nothing happens. I don't get solutions. Why not? We need to understand why not. The reason is Desmos doesn't know what c is, right? That's the whole reason you're getting the error. So here you want to tell Desmos what c is. And all it says is c is a positive constant. So just plug in a positive number, right? Doesn't matter which one you use, right? So I'm just going to go with 4, right? And now you see the error went away. And if I zoom out, I got my solutions here, right? So if I zoom in on this one, because all of these are negative, right? So if I zoom in on this one, because I can't click on it, sometimes you can't click on it, zoom in, zoom in, zoom in, you basically see your number. It's negative 47.17. That's the solution, right? The question is saying which of the following is a solution. So one of these is going to be this number, right? So which one is it? Well, just try it, right? You can type this in, right? You see I type in negative square root c squared plus 47 squared. And yeah, there it is. That's it. That's literally the same number, right? If I try the other ones just to show you it's not, right? 47 squared minus c squared. Yeah, that's not that number, right? And then negative c squared minus 47 squared. That's not it, right? And then last one is just negative c, which is definitely not it. So that's it. But it's really simple if you know you should plug in a number. So now, how do I know I can plug in a number here, right? General rule of thumb, if they tell you something's a constant, like they do here, as long as the question's not about that constant, so like here, the question is not what is c, you can generally plug in whatever you want for that constant. Well, not whatever, like sometimes they give you guidelines like here, right? So that's it in that case. If you know you can do that, this problem should be not too bad then. Okay, next one. If k minus x is a factor of the expression where n and k are constants, what's the value of n? So you can put this in Desmos, right? You see if I type this into Desmos, that's 1 over 1/16 nk squared, and then I type in this other one, k minus x. Nothing, a whole lot of nothing happens, right? But here's the thing, right? We can plug in some numbers, right? Because they tell you n and k are constants, right? And they do this to make it more abstract, right? But here's the general rule. As long as the question's not about those constants, you can plug something in for them. In this case, the question is, what is n? I can't plug in whatever I want for n, but you see, I can tell it like k is 3 in this case, right? They told me it had to be something greater than 0, so I go with that. Now, I still need to know what n is, right? That's why this one still has an error, but that's what the answer choices are, right? The answer choices are possibilities for n. So you see, I can try the first one. What if n was 1/16? Is that the right one? How do I know? Well, they told you this is a factor. Factor is a big key word here, right? Well, you want to remember with factors give you x-intercepts, right? So, you know, what you should see is this factor coinciding with this x-intercept if that is the correct value. And it doesn't, right? They don't coincide. So it's not that one. So then I tried negative 16, right? That definitely doesn't coincide with the x-intercepts, so that's not it. This doesn't even have x-intercepts. How about negative 1 over 16? Let's try that. Nope. Okay, and then finally, if we try 16, let's see. There it is, right? You see, now the graph coincides with the factor, right, at the x-intercept, right? So that's how I would know that is the correct one, right? Just got to remember this connection of factors and x-intercepts, right? They go hand in hand with each other. All right, next one. The function f is defined by f of x equals a to the x plus b, where a and b are constants. In the xy plane, the graph has a y-intercept 0, negative 15, and passes through 2, 9. What's the value of a and b? This is a problem where you could do a regression. So you got 2 points, and you're trying to figure out like the coefficients of the equation. That's a regression, right? 0, negative 15, 2, 9, right? The thing is, you know, this is exponential, but you see, it's not this exponential one that they have. You see, if you click on the 3 dots, they'll show you this is a times b to the x. That's different than this equation, right? Which is why this doesn't help us. So what do you do instead? Well, you could just write your own equation, right? So like this equation is basically this, right? Ax plus b, right? If you want to do a regression, there's a couple changes you make, right? Instead of writing x and y, you write x1, y1. Why? Because that's, you see what the table has, right? If you don't know why we do that. So y1, and then instead of an equal sign, you use the tilde, right? So that's the key next to like your exclamation mark and the 1 key to the left of that, right? And then you write a x1 plus b, right? And that's it. You see, I see my a and my b, and it wants us to add them. So I add them and I get negative 11, and that's it. So if you know how to do that, that's, you know, pretty simple actually, right? So yeah, just, it's not the one they have in the just regressions by default. So you want to know how to do that. Otherwise, here's what you would do. You can treat it like your points. It's literally an x and a y. So you could plug them in for x and y. You see, I can do negative 15 equals a to the 0 plus b. And then for the other one, I could do 9 equals a squared plus b, right? And then you can even have Desmos solve this. It's basically a system. Just change your a's to x and your b's to y, right? We need to use x and y instead. And you see we have a system, and these are where our solutions are going to be. So it's this one. That's why they told you a is greater than 0. So it's this one, right? A was x for us, right? So that's the alternative. I don't know what you prefer. I like the entering the regression. That's obvious to me, though. Might not be as obvious to you, but if you practice it, it could be. Okay, next one. Which of the following expresses the relative humidity of the temperature in dew point? Well, the question doesn't really help you out here, right? But the answer choices do. You see, you have an equation, and then all of these are solved for h. So what you got to do, rearrange this equation for h, right? Personally, I wouldn't do that. That's going to be like a good bit of steps, and a lot of times people do that kind of stuff wrong. So here's what I would do instead, right? If you type that in, obviously Desmos won't draw anything, right? But it will draw it if we replace the variables with like x and y in numbers. So I'm going to say d is y, t is x, right? And then for h, I'm just going to make up a number. I'm going to go with 5, right? Now I have a line, right? One of these is going to be the same exact line when I make the appropriate substitutions here, right? So the A says h equals. We made h 5, so it's 5 equals, and then it's 20 over 7. And then d plus t, so that's y plus x plus 100. Is that the same line? No, so that's wrong. B is the same thing, basically, you see, but with a minus here, so I just got to change this to minus. Let's see what happens. There it is, right? Now it's the same line. If I turn off the red one, there's the black one underneath it, right? So that's the same one. So yeah, we're done with that. That's it. All right, next one. Which of the following are solutions to the given equation? We love that word solutions, right? That means you can take your equation, type it in, and you should see your solutions, right? However, here we don't see solutions. We get an error, right? So it's important for us to understand why we have an error. And it's because Desmos doesn't know what A is, right? So in this case, we want to tell Desmos what is A, right? So, what would A be? Well, they tell you over here, right? A is some number greater than 40, right? So let's pick a number. Let's go with 42, right? Now you see my error went away. And if I zoom out, here are two solutions, right? And I can click on them even, right? Awesome. So I see my solutions. The question is, which of the following are solutions? So we see 37, so it's definitely Roman numeral 3. What about the other one? Well, it says A and A plus 1. Well, it depends on what your A is, right? We made A 42. So Roman numeral 1 saying 42. It's not 42, it's 43. So A plus 1 works then, right? Because 42 plus 1 is the 43, right? So we want Roman numeral 2 and 3, right? That's going to be our answer here, okay? And you can try, right? If you change this, you see 50. I'm always going to have 37, and then it's always one bigger than whatever I put for A, right? So if you know that, it's really simple. You can just put in Desmos, assign a value, and click on your answers. Okay, next one. The given function, f of x, gives the metal ball's height above the ground in inches x seconds after it started moving. Which of the following is the best interpretation of the vertex, right? So they like these questions about quadratics. You want to understand quadratic interpretations, right? We got a graph just for that, right? There's 3 critical points that they like to ask about, and you got to know what each point signifies, right? So here they're talking about the vertex. The vertex is about the max or min. Right away, you see, I need an answer choice that says max or min. So it's not A, it's not C, right? The y-intercept's the initial height, right? They're talking, A is talking about like the height when it started moving. That's kind of like, that would be like the y-intercept, which they could very well ask you. They're just not asking it here, right? They could also ask about the x-intercept. The phrasing for that, this is the one that usually actually throws people off, right? It'll be something phrased like when it hits the ground or like when it reaches the surface, something like that, right? So here we know it's going to be right away B or D, right? And we just got to figure out what that, in this case, minimum is, right? This is in vertex form, so you can kind of like look at this equation and just know the vertex, right? It's 5, 4. So I know the minimum height's going to be 4, right? Because like the 5 represents what x is, right? Which is the seconds, right? But even if you didn't know that, you see, just throw that into Desmos. And then you can click on it, right? Here it is. That's the minimum, right? But again, the final thing is both these look kind of correct, but it's what was the inches, right? Inches is y, x is seconds, right? So you don't want, 5 in this case, right? If it said 5, it reaches the ball's minimum height is reached at 5 seconds, that would be correct, right? But not 5 inches, right? So D is our answer here. Hopefully all that makes sense. You need to know those quadratic interpretations. All right, next one. Which expression is equivalent to this, right? So again, equivalent means they got to match. Here's what I would do for this one, right? There's a couple ways you could do it, but if you have this, you can just tell it numbers. Like right now, you see it doesn't know what A and K are, but I can tell it numbers. Like I can say like A is 2, K is 3, and it'll calculate it's 240. Now, if one of these are equivalent, right, they should also give me 240. So I can just try like A, 72A over K, not 240, right? Next one, it's basically the same thing, but it has K squared at the top. So what does that give me? 432. That's not it. So C is 36A and then K plus 1. Nope, that's not it. Last one is K squared plus 1 on the inside. Yeah, there you go. It's the same. And now you can see I can change A, I can change K, and these are always the same, right? Because that's what equivalent means. They would be the same. That's how I would do that. Just plug in numbers there and, don't even plug it in yourself. Just tell Desmos what they are and just, write in with the letters, right? Pretty straightforward if you know how to do that. Okay, next one. The function p is defined by p of x equals ax squared plus bx plus c, where a, b, c are constants. The graph of y equals p of x in the xy plane passes through 5, 0 and negative 1, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? Okay. If you've seen this before, it's not terrible. If you haven't seen this before, it's going to be really difficult, right? There's a couple other variations of it. There's one where they give you the vertex. Here they're giving us the x-intercepts. So you got to know your quadratic forms, right? So like here, you want to start in factored form, right? Because we know the x-intercepts, right? So I can go ahead and just like plug in, you see, I can write this equation because I know the x-intercepts. So it would be this. If my x-intercept's 5, it's got to be the factor for that x minus 5. And if this other one's negative 1, that other factor is x plus 1, right? So now I just got to FOIL this out so it's in standard form. So it'd be y equals a. If you FOIL out that quadratic, it's minus 4x minus 5. And then you distribute your ax squared minus 4ax minus 5a, right? Now you can identify your a, b, c, right? We only really care about a and b. So a is a, and then b is negative 4a, right? So if I do a plus b, right, a plus b is going to equal negative 3a, right? Now, this question is a could be question, right? You got to understand could be questions. What happens with could be questions is that they have typically infinitely many possible answers, right? So that's why like here, you see, I hit a dead end. Negative 3a isn't an answer, right? And that's because, yeah, you can't just end up with a number when it's could be, because again, there's infinite possible numbers, right? So what they're saying is one of these choices could be it. So you got to kind of meet in the middle, right? You got to use your answer choices to complete this problem, right? So A is saying A plus B could be negative 6, right? So let's try that. Well, A plus B for us is negative 3A, so could that equal negative 6? Well, now you see I can solve for something. And if I solve for A, I get A is 2, right? And that's correct in this case because they told us A is going to be an integer greater than 1. So that's what we got, right? Whereas like take the other one, for instance, right? If you did negative 7, right? It would be A is negative 7 over negative 3. Yeah, so that's not an integer, right? So that's why that one couldn't work, right? And then what if it equaled negative 2? Well, if it equaled negative 2, it'd be negative 2 over negative 3. Not an integer, right? And then finally, what if it equaled negative 5? It'd be negative 5 over negative 3. Once again, not an integer. And it's greater than 1, but it's not an integer, right? So yeah, that's how we can rule those out. And that one's not too bad, honestly, right? So just make sure you know your quadratic forms to know you have to start in a factored form there, right? All right, next one. In the given equation, a and b are positive constants. The sum of the solutions to the given equation is k times 4a plus b, where k is a constant. What is value of k? So, a lot of people, can get this one wrong, and it's actually not like too terrible. And there's like a thing you can do in Desmos to make it easier, right? Basically, I think the first thing you want to pick up on this problem is it asks you for solutions. And you should know that in Desmos, if you type in an equation, right, Desmos will show you the solutions, right? So the problem is here we won't see solutions right off the bat, and we want to understand why. And it's because there's a and b, and Desmos doesn't know what they are, right? In this case, to help yourself out, what you want to do is just make up numbers for a and b. And how do you know you can do that? There's a rule of thumb, right? They tell you they're constants as long as the question, and we can see that question at the end, as long as the question is not what is A or what is B, you can probably plug in whatever you want for A and B, right? Not whatever. Here they told you they have to be positive, but yeah, whatever positive numbers you want, right? So I can go like this. A is 2, B is 3. I don't like to use 0 or 1, right? You can't use 0, but I still don't like to use 1. And these are our solutions, right? Now I can like literally click on it. That's my solutions. And what they tell us is they tell us like, it says the sum of the solutions, right? So I got to add these two numbers together, right? So I'm going to take this number and add it with this number over here, right? And this is the sum of the solutions, right? And they say the sum of the solutions to the given equation is a key word in math, right? As equals, right? So it's like the sum equals k times 4a plus b, right? And then the question is, what is k? So yeah, you see, like k is the only unknown here because we know what a and b are. So what would you do here? You would just divide by this 4a plus b on both sides, right? And you see that's going to be k. Now to get a number, I think it's having an issue. Let's see, if I write k equals on this side, yeah, that's not a problem. It's just if it's on the other side, it doesn't like it. That's our number, right? And yeah, you can just enter it just like that. I think if you try and change it to decimal, it doesn't work because Desmos, these had decimals and Desmos just cuts them off at some point, so lose a little precision. But you got more than enough numbers to enter there, 0.142, and I can't fit any more. And I enter that and boom, that's it. It's done, right? So they do this on purpose, like to make it more abstract, right? But a lot of times this is how you can counter that. Just plug in numbers anyways, right? All right. So if some of those felt rough, that's totally normal. And here's the thing. Every one of those questions is live on Sigma Prep with a fresh variation. Multiple variations, in fact. Sometimes 6 or 7 of them. So you can drill them until they do become automatic. Repetition is simply the key. This is the practice section. The advanced math ones right here. This is exactly where this video came from. There are over 650 advanced math questions in here and only 20 made the video. I picked the ones you're most likely to see on test day. From there, you can go to the free practice test. Full length, real scoring. When you finish, you'll see exactly what you got wrong, and there's a video explanation on every single one, even the ones you got right. That way you can check whether your way was the fastest way or whether I did it in a more efficient way. So you get feedback no matter what. And now here's the part I'd actually use. When you finish a test, check this out. It takes the questions you missed and builds a quiz out of those concepts. Brand new problems, not the same ones handed back to you, different numbers, each with video explanations. Because watching a video feels like learning, but working a fresh problem on your own on the same concept is what proves it stuck. And you get this free, no subscription required. It'll also build you a study plan based off of your results. It places every topic based on what you actually missed and orders it in the way I'd order for a student of mine, with the most important, heaviest stuff, most likely stuff that you'll have to do every test coming first. Put in your test date here and it tells you exactly how much you need to finish each week to stay on pace. There are 24 full-length practice tests on here. Each one mirrors an official Blue Book test, and there are 3 variations of each one. So retake is never just a memory check. So you can do test 4 and do it 3 times. And each time you'll be able to check, did you get things right this time that you previously got wrong, right? That's how you know you're improving. And so all of this is free to start. Tons of stuff for free practice tests, free diagnostic quiz. You can do a little bit of each practice test, a practice topic actually for free as well. No payment to sign up, and the link is below. Next one is going to be geometry trig, same format. The hardest ones as well, that's going to be a good one. There's a lot of interesting ones there. Like and subscribe, and I'll see you in that next one. Take care.